While in configuration 4, again I am having the chance of it is 1/3. And now, how much is the chance that we will get configuration 2 or configuration 4? Because now the chance of it, configuration 2, out of the 13 we are having the chance is 3/13. While in configuration number 4, to get configuration number 4, the chance is 6/13. So we can calculate P5, and P5 will be 1/3 into 3/13 plus 1/3 into 6/13. And we have here 3 cancellation, and we are having 1/13 here, plus here 3 simplifies with 6, so 2/13, and they add up with 3/13. So here the probability of getting 5 particle, the 5 here, is more than getting P1. So we have P5 greater than P1. It means P5 is more probable in this setup, in this system, compared to P1. And similarly, we can calculate the other probabilities as well here. Let me calculate here P7. Now I will calculate them directly, and P7, you know that what is the chance of 7 in the 3 particle system? So it is 1/3, and I write 1/3, and then multiply it. Is 7 is here only, so what is the chance of getting configuration number 4? It is 6/13. So 6/13, and I get 2/13 as the probability of getting 7. So P7 is 2/13. What about P13, the next? After 7, we are having 13. So let's come here. 13 is here. So the chance of getting 13 out of the 3 particle is 2/3. So we got 2/3 multiplied by the chance of getting configuration 2 is 3/13. 3/13, and we got 2/13 here as well. And I can calculate the P17. First, 17 out of here. We have only 17 in this configuration. So this is 1/3. So this is 1/3 multiplied by the chance of getting configuration 4 is 6 here and 13. And we got this is 2/13 because this simplifies with this. And what is the chance of getting P19, the probability of P19, and come to 19, it's only here. So this is 1/3 inside the 3 particles. This is 1/3, and then the chance of getting configuration 3 is 3/13, and we got P19 is 1 over 13. Now, this should be true that if we add up all the probabilities, like from P1 to P2, P3, and all these up to P19, we should get 1 here. So I can do this thing. We are having P1, we calculated P1 here, which is 2 over 13. So P1 is 2 over 13 plus P2, P3, P4 are 0, and P5 is here, which is 3 over 13. Then P6 is equal to 0. P7 is 2 over 13. P8, P9 and up to P12 are 0, and P13 is 2 over 13 plus 2 over 13 and plus P19 is 1 over 13. Now 13 being the common, so 2 plus 3, 5, 6, 7, 8, 9, 10, 11 and 12 and 13. So we are having 5, 6, 7, 8, 9, 10, 11 and 12. Why we are having 12 here? Plus we have forgotten one for the P11 we have forgotten. So P11 here, P11. Now P11 is, if I look, this is 3 by 3 multiplied by, the chance of getting this one is 1 over 13. So this is 1 over 13. And we are having 1 over 13 for the P11. And now let's add up. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So 13 by 13, and it will give us 1 here. So of course, all the probabilities will sum up to 1. And now we consider the case of identical fermions, that what will be the situation there. Now we consider the case of identical fermions. So the particles are identical, and in addition they are fermions. Now for fermions, first the identical. For the identical, this state will exist, 3 particles, this and this and this. But now the total number of combination will not be this one, because it will be only 1. Here is the particles identical, so their switching in out is not possible, and we will have one possible way here and 1 here. But another problem is of the fermions, because 2 fermions cannot be in the same state. Here are 3. So this configuration 1, configuration 2, and configuration 3 are simply not possible, because we are having the same number, the repetition. Here means 2 particles cannot be in the same states. So the 3 configurations are not possible. Configuration 1, configuration 2, and configuration number 3, they are not possible. They are fermions. Pauli exclusion principle is here. No 2 fermions can be in the same state. And then we come to configuration number 4. The only possibility is of the configuration number 4. This is fine. But the particles are identical, so all these ways are not possible. Only one way is possible, is these are identical particles. So we will have the chance here is the total number of ways are actually not 13 but only 1. And now if I find the probability, for example, of phi here 5, P5 will be equal the number of chance getting configuration 4. Now it is 1. So 1 here, and the number of getting 5 out of this is 3. So we have 1 over 3 into 1. And this is 1 over 3. And similarly, P7 is also 1 over 3 here. P17 is also 1 over 3 here. So we got, now the sum of all the probabilities will be of course 1, P7 plus P5 plus P7 plus P17. 1 over 3 plus 1 over 3 and 1 over 3 is again 1. So this is for the identical fermions. Now if we are having the situation of the particles is identical bosons. Now bosons are not following the Pauli exclusion principle, so 2 or more than 2 bosons can be in the same state. So we have for the identical bosons here, this is one configuration is possible. 2. So number of ways is the particles become identical, so these number of ways will not be possible, but only one state here. This one way is possible. So 1 here, and 1 here. So we will have the total number of possible configurations is equal to 4. Possible ways are actually 4 now, instead of 13 which we were having for the distinguishable particles. So 4 are the number here, the 4 possible ways here, the total. And now I find the respective probabilities. So what about P1 here? P1, 1 here. So out of the 3, the probability of getting 1 here is 2 over 3. And what is the chance of getting this configuration number 3? The chance of getting configuration number 3 is, now this is only 1 here, because this is just the repetition of it, and only 1 is here. So 1 out of 4 is the chance of getting configuration number 3. Because the particles are identical, this state and this state are the same now. So this is not possible to have all these states, but only one state in each, one way in each configuration. And this is equal to 2 and 2 simplifies, and we will have 1 over 6 is the probability P1. Similarly, we can calculate the next probability, which is P5. Now, what about P5? We are having 5 here is here. So if I calculate here, this is 1 over 3. 1 over 3 multiplied by the chance of getting configuration 2 is 1 over 4 plus here it is 1 over 3, 1 over 3, and the chance of getting configuration 4 is also 1 over 4. So it will be the same thing, 2 into 1 over 3 into 1 over 4, and we will get this thing equal to 2 times 1 over 3, 1 over 4. So it will be simplified and we will get 1 over 6 here. I can calculate P7, and P7 will be, 7 is here only, so the chance of getting 7, this is 1 over 3, because out of the 3 we are having 1, 7 here, into 1, the chance of getting configuration 4 is 1 over 4, and we get 1 over 12. Similarly, P11, P11 is, this is the chance of having 11 in this 3 is 3 by 3. So 3 by 3, and chance of getting it is 1 over 4. So we are having this probability 1 over 12, 1 over 4. Similarly, P13 is here. So 13 here, 2 by 3, and 1 over 4. So it is again simplified 1 over 6 here. And P17, and P17 here is 1 over 3 and 1 over 4, so this is 1 over 12. And P19 is also the same because it is 1 only. 1 over 3 into 1 over 4. And this is also 1 over 12. Now the total probability should sum up to 1. So the total probability will be from here 1 over 6 here, 1 over 6, and plus another 1 over 6 here, and plus 1 over 12, plus 1 over 4, 1 over 6, and 1 over 12, 1 over 12. Now I can write this is 12 here as the LCM, and 2 plus 2 plus 1 plus 3 plus 2 plus 1 plus 1. And if I add them up, 4, 5, 8, 10, 11, 12, and the total probability sums up to 1. So it is very obvious that the result, the probability of the result depends on the nature of particles, that which particles we are dealing with, whether they are identical particles or they are distinguishable particles. And inside identical particles, it depends whether they are bosons or they are fermions. So as a summary, I can see that as the number of particles grows, their number of possible combination grows, and that state becomes the more probable or the most probable state. So we will do statistical analysis, and statistical analysis is always for a large ensemble of particles. So we will adopt a general way of counting the configurations or the combinations.